Example 1 will help you find the derivative of any inverse trigonometric function. It says find the derivative of y equals inverse sine of x by writing sine of y equals x and differentiating implicitly. So if we know, and this is by definition of inverse trigonometric function, if y equals inverse sine of x, then we can say that sine of y would equal x. This is by definition. Then we differentiate implicitly on both sides of the expression. We know that the derivative of sine of y with respect to x would be cos of y. Is something else missing? Yes, times the derivative of the inside, y prime. And that would equal 1. Derivative of x with respect to x will be 1. So let's solve it for y prime. Y prime would equal 1 over cos of y. But actually, I would like to express this in terms of x. What do we do? Oh, I'll show you a little trick. What you do is the following. Let's create a right triangle where sine of y equals x. Okay, here's my right triangle. Y would be my angle. And let's say that the hypotenuse is 1 to make it everything simpler. So sine of y would be opposite length over hypotenuse. But if hypotenuse is 1, it's simply opposite length. Oh, but what we know is the sine of y is x. So this opposite length would be x. And if we complete this triangle using Pythagoras, we know that 1 squared would equal x squared plus this length. So this length should equal, work it carefully, hypotenuse squared, 1, minus the square of the other side, a square root of all that. So we have completed in that way our triangle. Why do we do that? Guess what? This triangle is going to help us to put cos y in terms of x. Let's just get it from the triangle. Y prime would equal 1 over cos y. But if y is the angle, the cos of y would be adjacent over hypotenuse. And the adjacent is root 1 minus x squared. And that's the derivative. Now you can go ahead and prove what is the derivative of inverse cos x and the inverse of tan of x. After that, the most general expression would be, what if it's not sine of x but sine of a blob? In other words, when you have the derivative of the inverse of another function, you have a composite function, first you do the derivative of the inverse function times the derivative of the inside. Now give a try to sample 4. The answers are on Moodle, and then you can start working on your additional practice. And that's it for now. Bye-bye.